Welcome back friends. Today I am going to explain one of the most commonly asked BPPK concepts, how to calculate Km and Vmax using different graphical methods. These methods help us to decode Michaelis-Menten kinetics with just a pen, paper and a graph sheet. So these are the three graphical methods we use. First one is Lineweaver-Burk plot. So it is also called as double reciprocal plot or Plot's plot. Here the concept is we take the reciprocal of the Michaelis-Menten equation. So as we already discussed the equation of Michaelis-Menten in our previous videos, the equation for Michaelis-Menten was V equals to Vmax into C divided by Km plus C. So we have to take the reciprocal of this equation. So taking the reciprocal, so V becomes 1 by V and this Km plus C goes to the upside in the numerator and Vmax into C comes to the denominator. So separating the terms also, and after that we are taking 1 by V equals to Km divided by Vmax into 1 by C. This C we are taking separately plus 1 by Vmax. How 1 by Vmax? This C and this C gets cancelled out. After that we have to plot the graph. So on the y-axis we are taking 1 by V and on the x-axis we are taking 1 by C, as you can see here. So our interpretations, y intercept is 1 by Vmax here, y intercept is 1 by Vmax and x intercept will be the minus 1 by Km. This will get by extrapolating into negative Km and Vmax. So slope will be the Km and by Vmax. So this plot gives a straight line, so it's easy to find Km and Vmax from the slope and intercepts. So this is all about the Lineweaver-Burk plot. Let's see the second one. So the second one is Hanes-Woolf plot. Here the concept is we have to take the plasma drug concentration to the velocity V ratio. Okay, so we are taking drug concentration and velocity of reaction ratio and we are plotting it against the plasma drug concentration, which you can see in the graph. We are taking plasma drug concentration and velocity ratio here C by V and plotting it against the plasma drug concentration on x-axis. Next, so we are getting this equation by multiplying the Lineweaver-Burk plot with plasma drug concentration. We saw the Lineweaver-Burk plot just now, so you have to multiply it by plasma drug concentration to get Hanes-Woolf plot. So this was the Lineweaver-Burk plot equation and I am multiplying it with the plasma drug concentrations. So after simplifying, this equation becomes like this. This C and this C gets cancelled out and this C comes here. So Km plus C divided by Vmax. This C comes to the in the place of 1. 1 multiplied by C is equals to C. So when you're plotting the graph, you have to make sure that on y-axis C by V comes and on the x-axis C comes. Interpretations will be y-intercept is the Km divided by Vmax and slope is the 1 by Vmax. So this plot is more accurate than Lineweaver-Burk plot, okay, because it reduces error from low concentration values. So it is more accurate than the Lineweaver-Burk plot. Now we'll see the final one, that is Eadie-Hofstee plot. It is also known as Wolf-Hostinson-Hofstee plot. So the concept here is we have to start from the Michaelis-Menten equation. So what was that? V equals to Vmax into C divided by Km plus C was the Michaelis-Menten equation. So remember this equation. After that, we have the second step. In second step, we have to divide this equation by C. So it will become like this, V divided by C, and here also we have to divide it. So Vmax into C, Km plus C, and we are dividing it by C. So the equation becomes V divided by C as it is, and Vmax Km plus C. So this C and this C gets cancelled. Now the third step is you have to multiply on both sides by Km plus C. So I am multiplying it. See here, to this equation I am multiplying Km plus C on the both hand side. So this Km plus C and this Km plus C gets cancelled. So our equation becomes V by C Km plus C equals to Vmax. After that we have to simplify it. So this Km will be multiplied by this V by C, and this C also gets multiplied with it and equals to Vmax. So this C and this C gets cancelled out, and our equation becomes V equals to Vmax minus V by C into Km. This comes to the on the right hand side. We can write it as V equals to Vmax minus Km V divided by C. Hope you are getting this. Now we have to plot the graph. Plot y-axis equals to V, and on x-axis you have to take V by C. So our y-intercept here is Vmax and slope is the minus K. You can see here in the graph, on y-axis we are taking V and on the x-axis we are taking V by C. So our slope is the minus Km and our y-intercept is the Vmax. So this plot avoids the use of reciprocals, making it more reliable when dealing with experimental errors. Here is a quick summary table to make things easier for you. So firstly we have the method or plot type. Then we have the x-axis, y-axis, slope and y-intercept. The method which we have seen are Lineweaver-Burk plot and Hanes-Woolf Eadie-Hofstee plots. These are the three methods we have seen. So first one, on the Lineweaver-Burk plot, on x-axis we are taking 1 by C, and on the y-axis we are taking 1 by V, and slope was the Km divided by Vmax, and on the y-intercept we have taken 1 divided by Vmax. On the second one, Hanes-Woolf plot, on x-axis we have taken C, on y-axis we have taken C by V, and our slope was 1 by Vmax, with the intercept y-intercept was Km divided by Vmax. And the last one, Eadie-Hofstee plot, on x-axis we have taken V by C, and on the y-axis we have taken V. So our slope was negative Km and y-intercept was Vmax. So friends, these are three different ways to calculate Km and Vmax using just your experimental data and a graph. No fancy software are needed, pure basics. If you found this helpful, do like, share and subscribe to the channel. Thank you.